Hello friends. Friends, today we will discuss the summary of Maxwell's equations in differential and integral form with their significance. I have already derived and discussed all the four Maxwell's equations in my previous video lectures. Today we will just summarize these Maxwell equations. First of all, differential form. First of all, we will discuss the differential form. Now, differential form means in the form of del operator. Now, first Maxwell equation is del dot D equals to rho. That is Gauss law in electrostatics. This is first Maxwell equation. Second Maxwell equation is del dot B equals to 0. This is also known as Gauss law in magnetism. Third Maxwell equation, del cross E equals to minus curly B by curly T or del B by del T. This is also known as Faraday's law of electromagnetic induction. Fourth one is del cross H equals to J plus curly D by curly T or D by dt. This is also known as modified Ampere's circuital law. Here the D is known as, the D is the electric flux density or displacement vector. B is known as magnetic flux density. E is electric field intensity, and H is magnetic field intensity. Okay, here this D, okay, this is also known as the displacement vector, okay, displacement current, and the relation between B and H is B is equals to mu naught H, and D and E is D is equals to epsilon naught E. So by using these relations, these Maxwell equations can be converted into del dot E equals to rho by epsilon naught, del dot H equals to 0, del cross E equals to minus mu naught curly H by curly T, del cross H equals to J plus epsilon naught curly E by curly T. So these are the meaning of the terms used here, where rho is the volume charge density, first Maxwell equation, second Maxwell equation, third Maxwell equation, and fourth Maxwell equation. Now the integral form. Now the integral form of these four Maxwell equations that we have derived already. First is d dot ds equals to rho dv. Second is integral of b dot ds equals to 0. Third, integral of E dot dl equals to minus d by dt b dot ds. Fourth, h dot dl equals to j plus curly t by curly t dot ds. Okay, this is the summary of the integral form. Okay, now the physical interpretation. Now the part is physical meaning or significance, okay, or importance of these Maxwell equations. Now what was the first Maxwell equation? Del dot d is equals to rho, or d dot ds equals to integral of rho dv. Now what is the meaning of this mathematical equation? That is a total electric displacement, displacement through a closed hypothetical surface enclosing a volume is equal to the total charge enclosed within the volume. Okay, total electric flux through a closed hypothetical surface enclosing a volume is equal to the total charge enclosed within the volume. This is basically the Gauss law in electrostatics. Or what is the meaning of del dot? Now del dot meaning is divergence. Okay, that d or e, because del dot e is equals to rho by epsilon naught. That is, there is divergence of electric field, and it depends upon the volume charge density. If we know the volume charge distribution or the charge distribution, we can calculate the electric field. Second Maxwell equation is del dot b is equals to 0, or in integral form b dot ds equals to 0. Now it means that net magnetic flux emerging through any closed surface is 0. This is the magnetic flux emerging through any closed surface. For example, there is a magnet. If there is a north pole, if there is a south pole, okay, if there is a north pole and there is a south pole, and if the lines of force are emitting from here and it is entering here, net magnetic flux is 0. It proves that magnetic monopoles do not exist. Third Maxwell equation is del cross E is equals to minus dB by dt. That is, whenever there will be a change in the magnetic field, electric field will be associated with it. Rotational electric field will be associated with it. Okay. And what is the fourth Maxwell equation? Del cross H equals to J plus curly D by curly T, or J plus epsilon naught curly E by curly T. Whenever there will be change in the electric field, magnetic field will be associated with it. Rotational magnetic field will be associated with it. That is, whenever there will be change either in the magnetic field or in the electric field, there will be the change in the electric field or the magnetic field respectively. Okay, or in other terms, by integral form, EMF around a closed path E dot dl is equal to the time derivative of the magnetic displacement through any surface bounded by the path. Okay, so this Maxwell equation fourth introduces the concept of displacement current density also. So these are the four Maxwell equations, summary of the four Maxwell equations with their physical interpretation. I hope you have understood. If there is any doubt, please share in the comments section. Thank you. Thanks a lot.